Cursor underscore sharing, Oracle SQL performance, shared pool, hard parses, crisis. The hard parse crisis, your Oracle database is consuming 40% of that CPU on work that produces zero business value, not on queries, not on data processing, on parsing, on looking at SQL statements. It has already seen 100 times and pretending they are brand new because the literal and the where class is different. And the fix is a single parameter change that takes 30 seconds, cursor underscore sharing, three possible values, exact, force, similar. Most DBAs know the names, almost nobody knows the exact difference, and that difference is the entire story. This video is that story. It's all about cursor underscore sharing, about that exact versus force versus similar. A complete deep dive, hard parse, library catch, SQL performance regression. Okay, welcome to AA DBA Hub. I am your host Ramesh, and today we are going to deep on cursors underscore sharing. I am going to start with a parsing pipeline because you cannot understand what cursor underscore sharing does without understanding exactly where in Oracle's execution flow it intervenes. Then we dissect each value, exact first, and then force, then similar, with live demo showing what happens in $SQL under each setting, and I will give you the decision framework, which setting for which scenario and what to watch for after you change it. Okay, the parsing pipeline. The cursor underscore sharing, there are three suspects, one parameter, one dramatically different effect on your library cache, hard parse rate, and SQL performance. Select each suspect to integrate it, see exactly what happened inside Oracle shared pool. The foundation knowledge. Before we look at any of three settings, I need to walk you through the Oracle parsing pipeline in 6 stages. Syntax check, is the SQL grammatically correct? Semantic checks, do the object exist? Does the user have access? Shared pool lookup, is there already a cursor with the exact SQL text? If yes, soft parse, fast, cheap. If no, hard parse, slow, expensive, CPU intensive. And then execution. Cursor underscore sharing modifies the SQL text before the shared pool lookup, that its entire mechanism. It intercepts the statement and edit it so the shared pool lookup finds to match it. Without cursor underscore sharing, two statements that differ only in literal value are completely different from Oracle perspective. Okay, so the exact, force, similar. The exact is a default value, says cursor only on byte for byte identical SQL text. Best plan quality requires bind variables. This is a default value, right? So the default. Cursor underscore sharing is equal to exact is the default, and it is the right setting when your application use bind variables. With exact, Oracle only shares a cursor if the SQL text is byte for byte identical. Some white space, some case same literals, same case, same literals. If your application sends a same query with different letter values, Oracle treats each variation as a completely new SQL statement. Hard parse every time, new cursor in the library cache every time. Here is the diagnostic I want you to run right now on your database. It shows the hard parse ratio. If it is under 1%, your application using bind variables and the exact is working perfectly. If it is above 5%, you have a problem, and we are going to talk about force. Okay. So the exact deep dive, cursor underscore sharing equal to exact. This is default Oracle setting. Byte for byte. Identical SQL required to share cursor. So none of hard parse detection, literals and still Unix, and 100% cursor shared when SQL is identical, and less than 1% target hard parsing ratio, and 0 plan quality risk. Alright. So what happens inside v$SQL with the cursor underscore sharing equal to exact? So the application sends 3 calls, different application sends 3 calls, different literals. Select SQL query 1 where depth ID equal to 10, SQL ID 2 where depth ID 2 equal to 20, SQL number 3 where depth ID equal to 30. So 3 different SQL text equal to 3 hard parses. Alright. So library cache result exact mode, SQL1 cursor A depth ID equal to 10, loaded equal to 1, execution equal to 1. SQL number 2 cursor B depth underscore ID equal to 2, loaded equal to 1, execution equal to 1. SQL 3 cursor C depth underscore ID equal to 3, loaded 1, execution 1. So there are 3 cursors, 3 hard parses, 3 into memory, 3 into X memory. So the library cache slots filling exact 100 queries, 100 different literals. So application uses literals. It is using more number of queries, more number of different literals, more number of hard parses, cursors it's opening, right? So library cache SQL area 0 cursor. And let me simulate the 100 queries here. Literal SQL, unique cursor per literal. So let me simulate here. So it is running. So depth 1 to depth 100. It is opening 100 cursors, 100 hard parses. Okay. So when you are using literals, if you are running the queries, it will using 100 cursors and 100 hard parses. So the exact is correct when your application uses bind variables. When the absence where depth ID equal to colon depth not a literal, then it should be the exact value you should set cursor underscore sharing equal to exact. When the exact is correct, your application uses bind variables. All executions share one cursor regardless of value, 0 hard parses after the first. Exact reverse bind variables. It does not fix the absence of them. Okay, exact reverse bind variables. Okay, so that when you are using your application is using bind variables, you can go for by default value cursor underscore sharing equal to exact. So I am let me run this simulation. I am going to run this query. So cursor underscore sharing exact query. It is inside in this query. So we need to copy and run this in the production or that your test databases. your demo, your lab databases. So we can set this alter session set cursor underscore sharing equal to exact. Then run this 3 execution with the different literals. Okay, so this is a 3 different select query, 3 different literals we are giving input value 10, 20, 30. Okay, after setting cursor underscore exact. So now check the VDAR SQL, how many cursors are opening for this literal SQLs for those 3 SQL. Okay, so we can check through this SQL, VDAR SQL, where SQL text equal to employee department ID and SQL. So you can find out how many cursors are opened in this scenario, right? And again, you can open another session. You can set that session, select and cursor in exact, and you can select that query, and you can see the result. So the select SQL text parse execution loads where you can get that how many parses are you are getting. 1 hard parse, 1 cursor, 1 execution for each and every execution, right? Result 3 cursors, 3 hard parses, 3 index library cache memory consumed. So exact with literals is equal to no cursor sharing at all. So you should clearly understand cursor underscore sharing when your application uses the literals. This is not the right option. So if your application uses the bind variables, you can use it for the exact. That is the right option. So next, force cursor underscore sharing equal to force the life-saving setting. The cursor underscore sharing equal to force. This is setting that saves databases. When set to force, Oracle intercepts every SQL statement before the shared pool lookup and replaces all literal values with the system bind variables placeholder. So :sys underscore b underscore 0 : :sys underscore b underscore 1 and so on. The application sends a query with the literals. Oracle rewrites it internally with the bind variables. The shared pool sees the same SQL text regardless of what literal values application sent. 1 cursor, 1 hard parse for the first execution. All subsequent execution or soft parses. Let me show you this live. I am going to run the 3 identical queries with the different literal values. First under exact and then under force, and then we are going to see watch $SQL in real time. Okay, so force, what I can do, the replaces all literals with the sys underscore b underscore n before lookup. Maximum sharing eliminates hard parses storms, right? So here the force. So 95 to 99% hard parses reduction typical. So it will eliminate and one cursor for all literal values variations. And system bind variable naming, it is using for the system bind variable namings. And monitor version count, watch this space. So version count, we need to watch how much bind variables cursors opened, right? Hard parse rate before versus after. Okay, so before force exact plus literal, it is 85%, 2847 per second. So after force applied, it is 4%, it is 142 per second. That query elapsed time, it is reduced. How much you can see? It is how much it is reduced. So before it is after. And library cache hit ratio, before it was 61%, and library catch hit ratio after it is 98 percentage, right? So the literal substitution, what force does internally? So we can see application sends three literals, the where department 10 and 20 and 30. So three different SQL text, and the Oracle rewrites before pool lookup. It is writing sys underscore b underscore 0, and where dependence is in the b underscore 0. It is writing internally lookup, pool lookup, right? So one shared cursor, one hard parse, three soft parses. So you can see it is one shared cursor and one hard parse only, and it is going with three soft parses. So library cache slots force 100 queries or different literals. So you can see one cursor, one hard parse, 99 soft parses. So you can see the difference here. Depth equal to colon sys underscore b underscore 0 shared by all 100 queries. So one cursor, one hard parses, one hard parse, 99 soft parses. So the shared cursor, all 100 queries reuse this one slot. Force applied Oracle intercept SQL every SQL statement before the shared pool lookup and replaces all numeric string and date literals with sysbo, sysb1, etc. The pool sees identical SQL for all literal variations. One cursor, one hard parse, monitor SQL VDollar SQL text from VDollar where SQL like sysb, you will see the rewritten form. Okay, then we can run this cursor underscore sharing force SQL. It will set that in the database end. So you can set alter cursor and set cursor underscore sharing force, the three different execution with the different literals. So you can check VDollar SQL. So it will come up with the flag greater than 20. So it will, you can check the version count also. So what it will show, the VDollar output, it will show that exactly how much that cursor and cursors opened, and how much hard parses happened and how many soft parses happened. And after that you can set the force. You can see here, this is the output. So result, you can see one cursor, one hard parse, three execution. So Oracle transparently rewrote department ID equal to 10, 20 equal to sys underscore b underscore 0. So important point here is version underscore count equal to 1 is healthy. Watch for greater than 20, which is indicates cursor proliferation from optimization mismatch or bind type differences. So you need to check the version count also. If it is the version count is 1, it is absolute healthy. Otherwise, if you are saying that more than 20%, 20, which is indicates it is cursor proliferation, it happened. So you need to check in the optimization mismatch or bind variables type form differences, right? So now the risk with force bind variable peaking, when the first execution was a literal substituted query runs, Oracle looks the bind variable's value and generates a plan optimized for that value. If department I underscore ID equal to 50 has one row, Oracle generates an index scan plan. Now the next execution comes in with department underscore ID equal to 1, which has 50,000 rows. Oracle reuses the index scan plan. That might be a disaster. This is the bind picking problem, and this is where adaptive cursor sharing comes in. comes in. ACS in Oracle 11G and later deducts when a bind variable's values causes a suboptimal plan and automatically creates an additional child cursor with the right plan. ACS plus force is equals safe. I will show you the how to verify ACS is active and what to look for. Okay. So here it is that I described, right, bind picking risk. The plan generated first execution reused for all subsequent execution if dept ID equal to 1 has 550,000 rows but dept ID 19 has 1 row. Oracle might reuse that wrong plan. Mitigation ensure adaptive cursor sharing ACS is enabled. It detects the bind variables value plan degradation and creates additional child cursor automatically. Require statistics level typical or all. Alright. Okay. So next, cursor underscore sharing similar. Similar, do not use. It is deprecated now, right? Why it was retired? Cursor underscore sharing equals similar. I am covering it because you will see it in Oracle documentation and legacy databases. The intent was good, like force, but with intelligence. If there is optimizer detects the different letter values, need different plans because of histogram based data screw. It creates separate cursor. The problem, the similar is worse than both exact and force in practice. It generates unpredictable number of child cursor. It conflicts with the adaptive cursor sharing and it is significantly harder to diagnose than either alternative. Oracle deprecated it in 12C. If you are using similar today, change it force right now. Force plus ACS gives you the everything similar was trying to do, but reliably. All right. So that Oracle documentation, it is showing the deprecation notice and similar. So Oracle official position, the similar is setting has been deprecated. Oracle recommends using force is instead. Oracle 12C documentation, if you are currently running similar in production, mitigate to force immediately. Similar provides no benefits over force that adaptive cursor sharing does not already provide. Better and more reliably. All right. And the smart what similar attempted. The smart middle ground that did not work. Similar was Oracle attempt at a histogram aware cursor sharing. Share cursors like force when the optimizer determines different letter values produce the same plan but create separate cursors when histogram shows data skew might require different plans. The intent was good. The implementation introduced complexity, bugs, and unpredictable behavior that made it worse than both alternatives. So the diagram, similar unpredictable sharing decision. Scenario A, no histogram on columns, act like force, create one shared cursor, predictable. Scenario B, detects screw, create a separate cursor per literal value like exact. So scenario C, histogram exit plus high version count creates more cursors than exact cursor proliferation crisis. Scenario D, the ACS is also enabled in 11G plus conflicts with the ACS. Interaction support nightmare. All right. So why Oracle deprecated similar? The problem, similar behavior, force plus ACS alternative. Unpredictable cursor count may create one cursor or n number of cursor depending on histogram. Force plus ACS alternative. Force always one parent cursor. ACS add child cursors predictably. ACS conflict with adaptive cursor sharing 11G plus feature and force plus ACS designed to work together optimal performance. Diagnostic complexity cannot determine sharing mode per cursor with the deep investigation. Force all cursors have sys underscore b underscore n visible in SQL underscore text. Easy to spot. A latch overhead histogram checks adds extra shared pool latch activity versus force. Force similar mechanism less latch acquisition per statement. Support burden disproportionate Oracle support cases and known bugs. Force well understood behavior, well documented workarounds. Oracle recommendation deprecated, do not use. Force explicitly recommended to literal SQL applications. Alright. So you can run this cursor underscore sharing underscore similar. You can run this query, but if we will not use it anymore. Do not use it in production, and you can see the difference here, right? So result one cursor with if histogram exists, it will go as skewed data. Oracle detects unsafe to share separate cursor. So this is the demo for this. All right. So we $SQL output. You can run. You can see the output. So you can see the output. This is what it will happen. So recommendation, all the systems at cursor sharing force scope equal to both, right? This is the recommendation here. So next, head-to-head comparison. So we'll see that head-to-head comparison of these three the head-to-head comparison, exact versus force versus similar versus complete decision matrix. Okay. So the decision framework, the flow chart. So you can see criteria and exact and force. Default value, yes, exact is a Oracle default. Force no, similar no. Hard parse reduction, none. Required bind words in app. Okay. So force 95 to 99 typical. High but unpredictable. Library gets memory high, one cursor per literal. It is low, one cursor for all. Variable. Cursor count on 100 literals, 100 cursors, one cursor, 1 to 100 unpredictable. So plan quality, optimal, literal specific plans, risk, bind picking, mitigated by ACS, variable histogram dependent. ACS 11G plus interaction, full ACS support makes force safe, conflicts with the ACS. Histogram benefit, full benefit picking sees the first execution value, attempt to use unreliably. Diagnostic is easy, moderate be invisible, hard, unpredictable. Oracle 12C plus status, current, use freely, current, recommended. Deprecated, to not use. Best use cases, app uses bind variables. So when app uses bind variables, you can go for exact. Legacy literal SQL app, never. So the thing is, the decision guide, the decision framework, which setting to use. If your application uses bind variable, exact, done. Best performance, best plans. If your application uses literal SQL, hard parses ratio is above 5%, force enable. Force. Enable ACS first if you are on 11G or later. Monitor version underscore count. If you are currently using similar, force immediately. If you are not, if you are on a reported Reporting database where each SQL runs once exact parallel execution and plan quality matter more than one cursor sharing. Never use similar. The only scenario where similar good theoretically makes sense no longer exists in Oracle 12c and later databases because ACS does not seem same thing better. All right. So the decision one, does your application use bind variables? Yes, exact, default, optimal, no change needed. No, check hard parse ratio. So decision 2, if it is hard parse ratio greater than 5%, select $V resistor where name parse count hard. If it is apply cursor sharing to force, yes. If it is monitor, consider fixing up to use find varies, no, in this case. So decision 3, are you on Oracle 11G or later? You can enable ACS first and statistical or typical or then force. And no, apply force, monitor version count carefully. So decision 4, are you currently using similar? Yes, then mitigate to force immediately. Similar is deprecated. No, you are on force. Continue to monitor version count. All right. So this is that decision making problem. So and finally, live diagnostics. So detect hard parses problem. Find worst offenders, apply and validate force. So diagnostic SQL run. So it will run here and you can see the output. So how many hard parses, how many total parses, ratio percentage, and healthcare status, crisis, apply force now. So in this scenario, hard parses health check, your database is hard parses, it's increasing. Select hard value hard parses, the ratio it is in apply force now. The 86% hard parse ratio critical. Every 86 out of 100 parses is a hard parse. So database is spending 40% CPU on hard parsing before any query work. So action, you have to do alter system set cursor sharing equal to force scope equal to both. Right? So cursor sharing demystified, exactly the default correct when your app uses bind variables. Force is the life-saving emergency setting that eliminates hard parses terms from literal SQL application. Similar deprecated do not use. The most important takeaway note, check your hard parses ratio right now. The query is in description and on my blog at aidba.com. If it is so 5%, you have a hard parse problem. If it is above 15%, your database is crising in force in the answer. Like, right? And number 2, the diagnostic number 2, find worst literal SQL offenders. So run this query, find worst literal SQL offenders. So select count literal variables. You can see that variance, total parse, memory, KB is sample SQL. So it is using worst offender order table. Total 28, 40, 91 literal variants of the same SQL. So solution, you can go for cursor and sharing force, collapse all 28 into one shared cursor. So in this scenario, you have to go for force, right? And apply and validate force. So when to apply and validate to force? Let me run this query. So let's check here. So applied, so parameter, it is storing, cursor setting, and it is current exact problem state, alter system sorry, force scope. So it is checking SQL text and parse execution load, orders per order ID, it is 1 hard parse and 849 execution, and custom is equal to 1, employee salary it is on hard parse ratio 86 and 4 immediately after applying force, right? See, earlier it was 86%. After applying force equal to 4% immediately reduced, and library hit ratio is 61% become 98% after applying force, right? Great. So this is all about that cursor underscore sharing and that SQL query performance regression problem issue. So we could see we saw the complete all the three different scenarios, exact, force, and similar. So if you like this video, if it has helped, subscribe to AI DBA Hub. Tell me your hard parse ratio in the comments. I want to know what you find, and see you the next one. Thank you very much.